Okay, ladies and gentlemen, this is Miss Avila presenting the second half of your lesson for Wednesday, April 29th. And now this is a video from Amplify that we're going to watch about energy in a system.
The system is represented by the tank, and the energy is modeled by the orange water flowing through the tank. This top valve allows energy to enter the system, and this bottom valve lets energy exit the system. Right now, both valves are letting the same amount of energy enter and exit. Because of this, the system is stable, meaning the level of the energy in the system is not going up or down. The valves can also change the amount of energy entering and exiting the system. Let's look at two ways we can increase the amount of energy in the system. The first way is to open the top valve so that more energy can enter while keeping the bottom valve the same. We can see that the level of the energy in the system starts to rise.
Daniel.
Both valves have been reset to let the same amount of energy in and out. The second way we can increase the amount of energy in the system is to close down the bottom valve while keeping the top valve unchanged. By closing down the bottom valve, less energy can leave the system. This also makes the amount of energy in the system increase. Now we know two different ways to get the exact same result. Having more enter or having less leave both increase the amount of energy in the system.
Okay, so you can think of energy in the Earth system as these examples. The energy can increase, leading to an increase in temperature if more energy is allowed to enter the system, or if less energy is allowed to exit the system. In Chapter 2, when you see a new key concept, you're going to copy and paste it into Unit 7 Key Concepts list. So I'm back into our document. So here we have key concept number 6, stability and change. So you are going to copy this by selecting it. Andrew, stop.
Okay.
You're going to right-click it and you press copy. You're going to go into your key concepts document and you're going to paste key concept number 6 right there. Okay. Stop. All right, so then we go back into our original document. Key concept number 6. Thinking of selling an 8-year-old and almost 3-year-old if anyone's looking for one or two. Okay, key concept number 6, stability and change. A system can be stable even as something flows into and out of a system. If this balanced flow is disrupted, there may be changes to the system. Okay. You can see that a system is stable even as something flows into and out of the system. But if a change happens either to the flow into the system or the flow out of the system, that changes what's in the system. Many scientists consider when a system with inputs and outputs will be stable and when it will change. And thinking this way can help us with our questions about climate change too. Did we find evidence to answer our investigation question, how can the amount of energy absorbed by Earth's surface change? Well, we do have evidence that a change to either the amount of energy entering or exiting the Earth system affects how much energy is absorbed by the surface. I told you to stop. We have evidence that more energy entered than exited. When more energy entered than exited, then both energy at the surface and temperature increased. And we found that less energy could have entered than exited. When less energy entered than exited, then both energy at the surface and temperature decreased. So here's another key concept. You're going to copy and paste this into your key concept list in Google Classroom. Key concept number 7. is a change to either the amount of energy entering or exiting the Earth's system affects how much energy is absorbed by the surface. So for this, you are going to copy and paste it. Andrew, stop. And you're going to put it into that key concepts document.
Mama, look, Mama, look, jump. Mama, I jump.
He's not jumping. He's flying through the air and hitting me in the head. Stop. Okay, as we end today, let's watch this video about Earth's energy balance.
Did you know it's 212 degrees Fahrenheit right now where I'm standing? That's the temperature that water boils at. And when nighttime rolls around here on the moon, it'll get down to as low as minus 278 degrees Fahrenheit. That's cold enough to freeze gasoline, alcohol, and carbon dioxide.
What? Those are over 450 degrees apart? Now that's extreme.
That's because the moon gets the full force of the sun's energy when it's daytime. A little of the energy is reflected right back out into space from the moon's surface. The rest of the energy coming in is absorbed by the moon's surface, then re-radiated back out into space, mostly as heat, or the fancy term for it, thermal infrared radiation. Right now, where Alejandro is standing on the moon, he's feeling both the direct radiation and the re-radiated heat.
Dang, how are you not boiling right now?
That's a good question. I mean, I feel okay. But wait, why is it not the same temperature where you are on Earth? I mean, aren't we about the same distance from the sun?
That's right, and that means the incoming solar energy is the same for both. But what happens to that incoming energy is very different. There's a lot of factors that affect that energy here on Earth, but the biggest contributor to our country's climate is the atmosphere. Earth's atmosphere reflects almost 1/4 of the incoming solar radiation right back out to space. But it does absorb some of it, which is then re-radiated either out into space or back down to the Earth's surface as heat. The atmosphere also absorbs energy that comes up from the Earth's surface through things like evaporation and the Earth's re-radiation of, that fancy scientific term again, thermal infrared radiation. Certain gases in the atmosphere, called greenhouse gases, are really good at absorbing thermal infrared radiation coming up from the Earth's surface. When the gases absorb energy, their temperature rises and they radiate heat out in all directions, including down to the Earth's surface.
CO2 is a greenhouse gas. Even without people, there was CO2 in the atmosphere. The more CO2 we put into the atmosphere, it warms. Then what happens there is that there's more evaporation, and there's more water vapor in the air. And so then water vapor, being another very effective greenhouse gas, absorbs the energy. And so that leads to further warming.
If the energy coming in from the sun doesn't equal the energy going out into space, it means the planet is either warming or cooling. And there's a lot going on Earth that affects the energy input and output. It's complex, but if we take a few pieces of it at a time, it might make more sense. A small portion of the incoming radiation from the sun is reflected right back out into space by the Earth's surface. The amount of energy reflected back depends on the albedo, or reflectivity, of the surface. Lighter colored surfaces reflect more than darker surfaces. One of the most reflective surfaces on Earth is ice.
When you have a lot of sea ice, you raise the albedo, so the sort of bright ice discounts the dark oceans, so you get a cooling effect from that.
But I've heard that sea ice in places like the Arctic is melting because the Earth is warming. This must lower the Earth's albedo.
That's true. So the Earth will warm up even more, and we're changing albedo in other ways.
The urban heat island effect is a phenomena that we see where urban environments have a tendency to be warmer than surrounding rural environments because urban spaces typically have darker surfaces such as pavement, and so they absorb a lot of incoming radiation. One of the ways that we can make urban environments less warm is by painting every surface white. That would reflect more incoming radiation. Another way would be having a lot more green roofs.
And while some of the things that affect Earth's energy balance are out of our control, some of the variables we can control.
What temperature do you want to live in? How hot is too hot?
Okay, so please turn in this document. Go away. Please turn in this assignment when you are done. You're going to turn in this one. Do not turn in the key concepts assignment yet. You will continue to work on this for several days. Okay, so turn in this document, but do not turn in your key concepts assignment. All right, I hope everyone has a good day. I need to go control my little gremlins. I mean my kids. Bye.